Hi guys, I'm Darren, and in this video, it's finally here, INAV 6.0. Let's take a look. So that's right, yesterday evening, INAV 6.0 finally dropped. So what we're going to do in this video is do the usual thing that I do and see what's new in INAV 6.0 and look at why you should update. And believe me, this one, no matter what version of INAV you're running, you should update. There's a big change in this, which makes the whole flying experience so much better, so much safer, and just so much more enjoyable in general. So as always, I've created an article on the INAV fixed wing group, and we're going to just basically go through that article, going through each part in the article that I've broken down and having a general look at what's going on. And also I'll point out a few changes. Now, if you're not interested in this massive long video, I'm going to try and make it short, but no doubt it will be quite long. They always seem to end up quite long. The other day I made a video with Lee from Painless 360, and he's done a very short video about some of these changes too. So if you want a brief overview, take a look at Lee's video. And if you want a bit more in depth, then stick around and we'll also cover a few more points than we did on Lee's video. So first of all, let's have a look at the INAV fixed wing group article. So on my computer desktop, that's not there by mistake. This is something that always sort of gets ignored. If you are doing an update, read the release notes. Half the time, if you have an issue, they're in the release notes. So it is very important that you do read those. Read the release notes first. There's a lot of useful information in them, especially for CLI changes, that sort of thing, which will mean you probably won't end up having a problem in the first place. But let's head over to the INAV fixed wing group website, and I'll put a link to this in the video description. This article went live when INAV 6.0 went live, and basically we're going to be going through this in order. A few quick notes from this top section. This article doesn't cover every change. This has been quite a long development period for INAV. And we're probably going to see longer development periods in the future. So there's quite a lot of changes here, and in this article we've really sort of hit on the major ones and added things of note later on in the article. But if you wanted to go through and look at everything, there are two links here, one for the firmware and one for the configurator, and that shows all the pull requests related for that version. And also, if you're interested in who's done the work for you, these two links here show who has been working on INAV since the last version 5.1 was released and since 6.0 was released yesterday. Unfortunately, you can't tie things down to specific versions, so there could be stuff in 6.0 that was done before that date, and likewise some of the stuff towards the end of it could actually be for the next version. But it's just the time period from when INAV 5.1 dropped to the 25th of March when 6.0 dropped. So let's get on with it, shall we? Right, so the first section that we come to is for the most important change in INAV 6.0. And regardless of whether you think it affects you or not, it does. And for that reason, it is the most important change and is bringing some huge benefits to INAV. That is the update to the AHRS, which is the attitude and heading reference system. And if you've ever heard the phrase horizon drift is gone. And what horizon drift is, basically we have a real horizon and the flight controller needs to try and determine where that is. And the AHRS does this by using gyro data and other data to try and work out, where the horizon is. Now, a lot of people have a misconception that this only affects you if you have the artificial horizon line in the OSD. It doesn't. The horizon line in the OSD is purely a visual representation of the artificial horizon. It is an artificial horizon indicator, or AHI. The actual artificial horizon is used to calculate anything related to your flights. So if you have drift on it, it will affect everything from return to home, waypoint missions, even angle or horizon mode. They will all be affected by the artificial horizon being off. Acro, not so much, and manual definitely wasn't affected. But if you're flying a multi-rotor, for example, you don't have manual. So if you're flying in acro, you probably didn't notice, but if you're doing stuff like cruising and long range, it still can affect you. But as far as INAV is concerned, it is now a thing of the past. I say it's a thing of the past. This is not an excuse to make dirty builds. One of the things that caused horizon drift in the past was excessive vibrations and electrical noise. These can both really mess with the gyro. And actually during the test period, which has been a long time, we started with FP1, which is Feature Preview Release 1, which had this new AHRS in it. Between then, which was like October, to now in March, we've only really seen one instance of horizon drift. And it's because there was excessive vibration. And we're talking 20 Gs of vibration on the gyro. So that is ridiculous. But if you have a well-built aircraft, balanced prop, make sure that you have no electrical noise. So usually this is from the ESC. So this is why it's really important. If you see video noise on analog, I know a lot of digital filters it out, which maybe that's not such a good thing. But if you do see a lot of electrical noise in analog, you need to really stop that at the source, which means putting capacitors on the ESC to try and filter out that noise. Because that electrical noise doesn't just affect the video feed, it also affects stuff like the gyro. So if you've got electrical noise, that can cause noise in the gyro, which is not good. It can affect the regulators in your BEC. So it is very important and a good idea to clear up this electrical noise. But that aside, things are a lot better. So the guy we all really need to thank for this is Shota Hayashi, and he implemented the central fugal force compensation, which is what really did help get this off. Most occurrences of drift actually happen because of the gravitational pull on the gyro. So when you're doing a long slow banking turn, you have this gravitational pull, and that actually sort of shifted where it thought the attitude was. So the compensation for the centrifugal force is the essential part that's got everything working. So big thanks to Shota, but it's also worth mentioning Julio Cesar Matas, who also was working at the same time on another fix for horizon drift. So yeah, this is the biggest reason to update to 6.0, and you may not even realize you need to, or you would benefit from it. But believe me, whatever version you're running, unless there is a reason like you're on an F3 processor, well, that's really the only reason. Update. If you're on 2.4, update. There's no golden version. This AHRS is going to obliterate all those old versions. This is INAV reboot. This is where you want to be now. If you wanted to check out those pull requests, they are in here. Let's get on to the next one. So the next change is RTH Trackback, which is a feature that's been asked for a while, and a guy called Bread Oven has implemented this, and it works really well. Now, originally this was going to be just for failsafe, but it was also added as an option for return to home. So you can choose whether you want to use it there or just use it on failsafe. But the whole idea behind this was if you lost signal, the plane or multi-rotor would turn around and fly back exactly where it was before. So it had the best opportunity of reconnecting to that RF signal. Now there are limits to this because there's only so much space we can store stuff on the flight controller. So there are two limiting factors. One is called trackback points and the other is a total distance. Now trackback points are recorded whenever you sort of deviate. So if you change direction or attitude, then it will record trackback points for that. So if you're flying a lot of acro, making a lot of maneuvers, you obviously are recording a lot of trackback points in a smaller space. Whereas if you're just cruising, you might not record trackback points for some time. So that's one of the parameters. The other is the maximum distance, which can be up to 2 kilometers. You can actually set the maximum trackback distance you'd like. By default, it's actually 500 meters, which for most people on average will probably be fine. But if you wanted to extend it to 2,000 meters, that's the maximum, or the minimum is 50 meters. So there is options to change that. Of course, if you wanted to investigate this further, you can click on these pull requests and take a look. This is the main one here. So if we open that up, you can see that Bread Oven's gone into quite a bit of detail with this, and there's a bit of discussion. And I think that's Bread Oven's tests. Mark Hoffman and Jetro also did quite a bit of testing with this, and yeah, it works very well. So you can see that there's been a lot of work done on this, and yeah, it's going to be an advantage, especially if you fly in sort of hilly areas. If you fly behind a hill and lose signal, the last thing you want is for the plane just to turn to home. And if you haven't got climb first on, or your RTH method doesn't allow it to climb above the hill, then you're going to fly straight into it. With this trackback, it will fly back along the path that you came in from, so it's much better. There is of course a caveat. If you're flying a fixed wing, you still have to turn around. So there is that loiter radius which it will use to make that turn. If it doesn't get around that turn before it hits the obstacle, then unfortunately that's just bad luck, but there's nothing that can be done about that, unfortunately. But once it's made that turn, it will come back along that path. What happens once it reaches the end of the 50 points or the maximum distance, it then activates the standard return to home procedure. Whatever you've got set up, it will just do that. So if you are climbing to a certain altitude, it will then proceed and do that for you. So that is the RTH Trackback feature. Next up is the wind estimation. Originally, you may as well have not even had the elements on your OSD. It just wasn't accurate at all. But now, thanks to these changes, which I believe Roman Lutt is responsible, yep, the wind estimator is now really good and pretty accurate, and it's been tested again quite extensively. So all you need to do is sort of not fly straight for too long. So if you are varying course, it knows where it's headed, it knows sort of the speeds it's going, and it's going to go on a different course. It knows that course and the speeds it's going. If you do like a loiter or something like that, it can work it out as well. But once it's got that wind direction and wind estimation, you're good for about 15 minutes. And then once it gets to that stage, it says, right, we've not changed anything. The wind may have changed, so we're going to say that this is stale. At that point, your units that it's basing this wind speed on, so if you're using kilometers an hour, it would be kmh, that will then start flashing with an asterisk every couple of seconds, just so you know that the data is stale. If you get that, again, if you just sort of do a loiter or just sort of meander off course a little bit, it will get that fresh data back, and then you're good for another 15 minutes with the wind speed. Another thing that has happened because of this accuracy is the virtual pitot tube is now very accurate as well. So this has been re-added back into F411 and F722 flight controllers, because before it wasn't really that accurate because the data it had to work on wasn't that accurate. Now it's pretty bang on, so we can use this as a guide for if we're close to stall speed, that sort of thing. So again, a very useful addition to INAV 6.0. Next up, we have landing detection. Now, I wasn't actually aware of how long this has been in INAV until the video I did with Lee, because it's mostly been on multi-rotors, but it's been in INAV for a long time now. But now it is also on fixed wing, and it's been improved quite a bit as well. So the landing detection is much more accurate. It's actually so accurate that it is on by default. And I didn't actually realize this change was in place until I sort of landed my Alba bird, was talking to someone, put my goggles back on, and noticed that the stats screen was there because it had disarmed by landing. So it's pretty useful. It just adds that extra layer of safety because it will disarm your craft even if you forget. Now, there have been some concerns about people who have landing gear and need to taxi away, but to be honest, if the aircraft is still moving, then you're not going to have a problem. You can just carry on. And to be honest, when I land stuff, I don't usually bring it to a dead stop and then start moving again. It needs to be stopped for a timeout. I believe it's about 2 seconds before it will do the disarm. So you can obviously land, bring it in slowly, taxi back to yourself, stop and disarm. If it does disarm, all you need to do is lower the throttle and arm it again. There's not really anything taxing about this, but I think in most cases you won't even need to go that far, so no problems there. Next up, we have the hardware in the loop, or HITL, which I made a video about, so I'm going to put a link up in the top corner somewhere. So if you want to know more about HITL, check out that video. And exciting news is SITL will probably be in the next version of INAV, which is software in the loop, which means that you don't actually need to use a flight controller. It will all run off of a program on your computer. But also the great thing with that is it means that there's a demo mode for configurator, so you can use configurator without having a flight controller set up. So that's another great thing coming in the next version. So yeah, look forward to 6.1 or 7.0 when that drops. Okay, so this one is quite a biggie. These are the OSD updates, and most of this has been for HD. There are some new elements for all OSD systems, but the HD systems have been overhauled, let's say. So in the last few versions of INAV where you could use digital FPV, there was basically two things. There was the DJI thing, and then there was from 4.1 HD0. The HD0 option implemented the MSP DisplayPort, and you could just set up your OSD as you like. On the configurator, it actually gave you that 16:9 window, so you could put stuff where you wanted it. Yeah, it just worked a treat. Then along came the Flip DJI, and they added an MSP DisplayPort implementation for the original DJI stuff. So you flashed their firmware on the DJI goggles and the VTX, and then you could use in INAV the HD0 system to set up everything on the OSD, and it was far better than the original DJI stuff. So hopefully no one is still using that original DJI stuff. If you're using the older DJI system, hopefully you're using the WTF OS and just getting a much better experience. Now in 6.0, this has gone a step further. So if you're used to setting up the ports page, you'll notice that the HD0 VTX is no longer there. You actually just choose MSP DisplayPort, and that works with HD0, Walk Snail Avatar, WTF, and DJI O3, which we'll get into in a little bit. If you're using the original DJI system without WTF, the original DJI VTX is still there, but seriously guys, what are you thinking? WTF it? Really? Trust me, it's better. But anyway, you just choose that MSP DisplayPort, and if you're coming from Betaflight, don't click the MSP button the other end. You don't need it. I wish in 4.4 on Betaflight they'd actually got rid of that. You don't need it. You're using MSP DisplayPort. It knows it's MSP. You don't need to set it twice. So yeah, just peripherals, MSP DisplayPort, all done. But yeah, the next step is to go to the OSD page, and actually let's bring that up. So let me just show you what I was talking about. All we need to do is say we're on UART 5, we go here and we choose MSP DisplayPort. You notice HD0 is no longer there, so we choose that. Do not click this button. Any Betaflight developers, please change it so you don't need to click this button. It knows it's MSP. Why? Anyway, so you click that and save and reboot. Once we're back, we head into the OSD page. And once that's loaded, we can choose what we want. So you'll notice that we're on PAL. That's because I've just switched over from analog. But also, if you want to use the 4.3 boxy set up for HD0, you can use this PAL setting. And then you can see we have HD0, which gives you a display that size. We have WTF, which gives you a display that size. And we have Avatar, which gives you a display that size. All three systems have different pixel grid sizes. And the Avatar is actually my favorite. It's a little bit smaller than the WTF, but it's an odd number on the horizontal axis, so the crosshair is actually centered. Yay! So yeah, we can actually center things on here. And anyway, the last option is BF43 Compat, which is for the DJI O3 system. So if I click that, you'll notice that it stays in 4.3 PAL size. The reason for this is because that is all DJI O3 can do. They've basically taken the analog Betaflight size and they're using that. They also only use the Betaflight font. So for example, these nice wind speed readings that we get in INAV, there is no wind direction symbols in Betaflight, so you'll get question marks where those symbols are. It's not great, but at least it's something, and there's nothing else that we can really do about this. DJI need to implement MSP DisplayPort properly with user upgradable fonts. Simple as that. If you don't like what this is doing, moan at DJI, please moan at DJI a lot. They're not going to do anything unless you do. They don't care. If they cared, they would have seen what WTF did, and they would have sorted it out in this new release. So yeah, you can set your OSD up as you want, depending on what system you're using. Just set it up, save, all good. Everything will work fine. So that's the stuff that you get to see that's changed, but also there's some back-end changes just to make everything a bit more in line with Betaflight's MSP DisplayPort, and also to send full frames over every so often. Previously, INAV only sent stuff that had changed. What we've done is implemented something in INAV which will actually send everything over to the VTX every so often. You can change the interval, but the default seems to work pretty well, and that will keep everything fresh. So you shouldn't see anywhere near as much of the artifacting, so that's odd numbers and values on the screen. If a value disappears, it should come back a lot quicker because everything is getting updated and refreshed. So that's behind the scenes. But you can see there's quite a few changes for the OSD in general, and a lot of them are, you can see a lot of it is for trying to hack this DJI 03 stuff in there. Right, so on to the next one. Now this is for people who use what the artist formerly known as INAV Radar, or now ESP32 Radar, because the idea is that it will work on other systems too, so it's not just going to be limited to INAV. And actually I know that someone is looking at setting it up on ArduPilot, so yeah, ESP32 may actually be the right name for it pretty soon. It won't just be an INAV thing. Originally on our head-up display, this is the sort of layout that we would see for the other aircraft. So we would have letters A through to D for the up to 4 craft. You can see we have the RSSI, we have a relative heading, which if you don't know relative heading, right, if we're tops of my fingers are the fronts of the plane. So if we're both flying like this, the arrow would be straight up because we're both going the same direction. If I was further back and like that, then the arrow would point to the left, I think. Because we're at a slightly different deviation. Of course, if I straightened up, then the arrow would point straight up. So that is that arrow. We have this arrow here, which will either show up or down, and that is also indicating that this is showing the altitude difference. If that arrow isn't there, it's showing the distance difference between the two craft. So from this, you can see that actually the other craft A is 32, whatever your units are, above you. So if for the sake of argument we'll say I'm flying with meters, craft A would be 32 meters above me. And these arrows here are the bit that really instigated this whole change, because they just were pretty confusing and not overly helpful, to be honest. These chevrons here, which you could have none, 1, 2 or 3, are saying you need to go that way, or you need to go that way. But all it is chevrons. So if it's 1 chevron, it's like you need to go that way a bit. If it's 2, it's like you need to go that way a bit more. If it's 3, you need to go that way a lot. It doesn't really let you know where the other plane is, other than you need to turn. And of course these arrows would appear on this side of the POI if you had to turn the other way. But it wasn't overly intuitive, and yeah, we've improved it. You can see that the relative heading, the craft and the RSSI is exactly the same. And if you're in the altitude, then the up and down is also exactly the same. One thing that you may notice is I'm showing 2 digits here, but it's shifted over a space. So we have an empty space here. Whereas here, you've got this empty gap, but it was never ever used because these chevrons can move. So because we now have something that's there all the time, we can just move these over, which means we have an extra unit for the data. So on this altitude, you can see I'm 16 meters above the other aircraft, but we could have a 1 here. I could be 116 meters above, whereas before the maximum would be 99 meters above or below. If it exceeded that difference, you would just only ever see 99. And the same goes for the distance as well. If this arrow wasn't here, we would say, right, I'm 32 meters away, but that would only go up to 9 0.99 meters away. ESP32 radar can do up to 4 kilometers. So once you've got in excess of that 999 meters, then you'll just be sort of guessing how much further away they are. And of course, if you're using feet, then it's even worse because you have sort of about 3 feet to a meter. Whereas now, because this has moved over and this arrow isn't here when we're showing distance, we have 4 digits. So now we can go up to 999 meters or feet away from you. So it gives you a much better idea of the distances. This here is the biggie. This replaces what these arrows did on either side. And what that does is just point at where the plane is. In this example, the plane would be over in that direction. So I can just rotate until that line is pointing straight up. And then I know I'm pointing towards the plane. But if it was sort of down here, I'd know it's behind me over my shoulder. If it's down there, it's over that shoulder. It's just a much quicker and easier way of knowing exactly where the other plane is. So that's the big changes with ESP32 radar. But there is an additional change that comes in with the next update. Pan servo compensation is something that is actually very useful for people running pan and tilt or even just pan setups. And unfortunately, not many people even knew it existed. This has been in INAV since 3.0. And what it does is when you turn the camera, it will compensate for certain things in the OSD. So for example, I'm pointing straight ahead at you. My home position is over here. My home arrow is doing that, right? If I turn to look at my home position, on the OSD without this set up, the home position would actually follow my view. So if I turn, it's now saying that the home position is behind me when it's not, it's there. So it's giving me false readings. What this pan servo compensation did, and it was only ever on the home arrow in the first instance. I'm looking at my home arrow is pointing here, here's home. As I turn, it actually compensates for the direction I'm looking in and will still point to home. So that is brilliant. It's very, very useful. And this has been extended now to the HUD. So this is waypoint POIs and INAV radar, just to give a couple of examples. So if the other plane was over there, so my box will be over here to show where their data is, and also the cardinal indicator will be pointing that way. As I turn, the box with the POI information on will stick to about where they are. So as you turn, it will actually sort of center itself. So let's give a better example. It's over here. I turn, that so let's give a better example. So the box is over here on my OSD because that's as far as it can go. As I turn, it will start to center when it gets closer to this aircraft. And also the cardinal indicator, which is pointing sort of that direction, as I turn will come up to point straight ahead. Same with waypoints. If you have a waypoint marker over here, you're flying in this direction, the waypoint a sort of arrow is going to appear about here in the OSD, but as you turn, the waypoint arrow will sort of move closer to the middle of the screen so it aligns properly with the waypoint. So it's really useful. But even then, extending it to use it for HUD things like the waypoints and ESP32 radar doesn't really make a difference if people don't know how to set it up. So that's where configurator comes into it. If we scroll down, we now have this pan servo setup. So what we can do is click on here and choose the servo. So let's head back into the mixer, and I'm going to add a servo for my pan. So let's just add a mixer rule. We'll set it on servo 5 and I'll stick it on RC channel 13. Let's do a save and reboot. Now, one thing to note is this is using the servo index here. So this will actually be number 5. It's not the output mapping port. So we'll be connecting the servo to servo 7 in this case, but we're actually looking for servo 5. So we go back in the OSD and then we drop down to our pan servo. We can see in here now we have servo 5, RC channel 13. So we know that's our pan servo. We can set that up. We have the total degrees, which I will do a video of how to set this up later on, but you could sort of roughly measure it and put that in there. And we also have a couple of settings now for a pan indicator. So if we go back up, you can see here we have a pan servo centered indicator here, which I can bring down. And that is basically a couple of arrows. So if your pan servo is centered, I think you see a little circle. If you pan to the left, you see the arrow going left. If you pan to the right, you see the arrow going right. Nice and simple. We can also add the degrees that you've panned, which is actually going to be very useful for setting this up. And also there is an off-center warning. And the idea behind this is if you basically put your pan servo where you think is centered, if it's not actually centered, it will start blinking after a while. It's just to let you know that it's not dead centered and you need to just adjust it. Of course, I'd recommend on your transmitter, when you're doing a pan servo, have a bit of a dead zone in the middle, so that when you're in the middle, it's definitely going to be 0 for maybe sort of 5–10% of the movement. But yeah, I'll do a video in the future about setting this up. I'm going to do a head tracker thing for INAV as well, and we'll get the whole setup done. But this is just the basics, just a quick way of showing you how this is now implemented and how it's going to be easy to set up and you can get your benefits from it. Right, next up we have a simulated AHI ladder. Now, if you used to use the FreeSky Pixel OSD, or you still do, you'll know that it has a really nice proper AHI ladder. So as you pitch up, the AHI is obviously going to come down here, but you'll get ladder increments of different degrees, so that as you pitch up, you can still see where level is and also a number of degrees. Especially if you're doing stuff like a lot of vertical and acrobatic stuff, it's sometimes quite useful to see where that is. There is now a change that will allow you to have this in the OSD. Now, if we have a quick look at this, we can check this out. So this is disabled by default, and what we do is set, it doesn't actually say the command in here. Right, so we have OSD AHI pitch interval. So let's jump into configurator and have a look, see what it's. So at the moment it's set to 0. Right, so if I take my flight controller and pitch up, you can see the OSD horizon line goes off when you get to the bottom of the screen. What this setting allows you to do is set an interval in degrees for when it redraws that horizon line. So let's say, I don't know, 30 degrees. And we'll save that. And now if we pitch up, what we'll see is that horizon line will disappear, but then reappear in the middle of the screen. So you can see it's not as good as the Pixel, but it will give you something at least. So yeah, you can see as the aircraft rises, the horizon line reappears. I mean, 30 degrees looks quite small actually. You probably want a bigger interval than that, but that's it working. You can see it works when you pitch down as well. Right, so next up we have some more OSD changes of note. So these are things that you might find interesting. So we have glide distance, remaining glide time, and climb efficiency. So let me just quickly show you those. So these are in the general area. So we have glide time and glide range, and they sort of work with the glide slope. So what these will do is if you have glide time, it will show you how many minutes you have left to glide until you touch down. Obviously maintaining the exact same angle and speed. And we have glide range, which gives you the amount of distance that you can maintain the current glide path for. The climb efficiency is in the current meter section, so you can see I've already got it enabled on here. And that will basically tell you the milliamp, or that will actually tell you the amp hours per meter or per foot that you are climbing. So if you're in metric, it will be meters. If you're in imperial, it will be feet. So that the lower that number is, the more efficiently you're climbing, or the less power you're using to go 1 meter or 1 foot. So that is those two. Change the HUD offset. So yeah, while we're in here, we can check out this. So if your camera was tilted down or up, you would notice that the AHI wasn't necessarily level. So what we can do is shift this whole section up and down. Before, you had to do that in CLI, but now you can do it in Configurator. If you've used this before, you'll notice that it's now working the opposite way around. Originally it worked this way around, but then the 0 position of the OSD was changed, and then it started working backwards. Now it's working the correct way around, or the more intuitive way around. So above 0, so 1 and 2 is up and negative is down. If you are using this setting in your older version of INAV, so your 4.0, 5.0, whatever, you will need to invert that value. There is a CLI update tool that will actually do that for you, which we'll get into at the end of the video. Right, heading graph has been fixed for pixel OSD. I don't really need to show you that, but just so you know, it has been changed and fixed. Correct symbols have been added for remaining time and distance. Right, the size of the INAV logo has changed. Now this is something that most people won't ever notice or won't ever care about. But if you're one of those people who like to make your own custom fonts and have your own logo on the font, then this gives you a bit more room to play with. It doesn't actually take away from anything that was on the font file before. There was actually space around the logo, so it's basically just using that space that wasn't used for anything and allowing you a bit more freedom. So it means that potentially we could have that like winged INAV logo or whatever. So you may have noticed when I rebooted my flight controller that I have my logo, and it's actually wider than just the square original INAV logo, and that was made possible because of this change. OSD elements for ground course and track error. So I need to go back in the OSD page. So the ground course is the direction that you are actually moving, not necessarily the direction you are flying. That's the heading. So we have two things on our aircraft. We have a heading, which is the direction the aircraft is pointing, and we have a ground course, which is the direction the aircraft is moving. So if I bring up the heading graph, this is north, south, east, west. This is which direction the flight controller is actually pointing. As I rotate the flight controller, you can see that that is pointing. Now, if we're flying with a crosswind, we can't point the same direction that we want to travel. We have to sort of point into the wind so that we fly in a straight line. And this is where the ground course and the error come in. So let me find where those are. So here we have the ground course, which if I bring that up, and also the heading. Now the ground course is probably not going to work at the moment because we're not actually flying, but if I turn it around, you can see that they're both staying fairly similar. If we were flying in a crosswind, what we would actually find is that the ground course will be different to the heading. So we want to fly dead north, which is 0, but we have a crosswind coming in from the right. What we would need to do is point into that crosswind. So we could have a heading of say 5-10 degrees, but the ground course would be 0 degrees. Missing alarms. There were some alarms missing on the OSD which you could have access to, so these have been added on there. This doesn't only show the information if there's an alarm, it just means that some of this stuff wasn't there before, but you can have alarms to it. The code was there, and it was just that you had to set it in CLI. So this has just made the alarms more accessible and given you a few extra alarms. Right, enhanced character map document. Now this isn't really going to be important to most people, but if you are someone who does create fonts, then this will be quite handy. So this is more for people who like to edit their own fonts, that sort of thing. So let's take a look on GitHub at what's changed. So if you're used to editing fonts, you would have usually gone into this OSD folder here and you would have seen a load of stuff for the analog font. That has now moved into analog, and everything is here as you would expect it. If we go back into OSD, you'll see now there is this digital folder which also contains font icons, which are actually the ones used in the Walksnail firmware. And if you want to edit those, there's some information there about how you can edit those. The character map in that PR is exactly what it says. It's basically telling you the variable names, the description of what it is, and the IDs, and also a preview image. So this was basically, Betaflight have got something similar to this, and this has been added into INAV, so it makes it a lot easier to see what the fonts are. And just to make it even easier, we're using the digital version of the font. So here you can see the logo, which I mentioned was made bigger, and a lot of that is hidden. You can see how it's been extended out from the side. Originally it was just cut straight down there, so we get a little bit more width. But yeah, so that's all the symbols in the current INAV. And here you can also see the pan servo symbols that again I mentioned earlier. But that is that change. Pilot name. So yeah, here we go. This is something that people have been asking for, and you can now have. You can just set yourself a pilot name. You can have an independent craft name as well. So you can see here I've got INAV 6.0 for the craft name, and here I have Mr.D as the pilot name. And obviously pilot name you put on all your craft. At the moment it is just an OSD thing, but we can add it to the ARM screen later. In a similar way to the enlarged logo area, this is really for enhancing things going forward. So maybe in 6.1 or 7 we'll see like a nicer arming screen, that sort of thing. Auto level added to system messages, yay! So we all know there's this auto level mode, which if you don't know about it, it is not a mode that automatically levels the plane when you let go of the sticks. That is horizon or angle. They are flight modes. Auto level is a tuning mode which determines the angle of attack when you're flying hands off. So for example, we fly at 50% throttle, we put it in angle mode and we enable auto level. Don't touch the sticks. What it will do is adjust the angle of attack so that you don't lose or gain altitude. That is what auto level does. But up until now, we don't really know that it's on other than we flicked a switch. Going forward in the system messages, it actually lets you know that auto level is active. And also there have been some changes to take auto level into consideration on the adjustments as well. So lots of nice things for auto level. Right, so that's the OSD stuff. Now for programming framework. Like always, the documentation is quite useful. So there's a link to the documentation here where you can see all the what you can do. So the big things to note in the programming framework. Firstly, there are settings now for timers, which people have been asking for. So let's check out programming. So the descriptors have changed a bit as well. So you can see now we have equal A equals B. This is more similar for people using OpenTX. So we have a similar sort of example to what you'd see in there. So approximately equals, that's a new one. So that's if the value in here, which you could obviously use, you know, global variable, RC input, anything like that. If that value is within 1% of this value, then it will be true. If it isn't, it will be false. So if we have 100 here and we have 99 here, that should be true. But if we have 98 here, that should be false. So there you go, approximately equals now in for the programming framework. The next one is also from OpenTX. Now this is detecting a change. So this is the delta logic condition. And what we're going to be checking is if the value in here has changed, which could be a flight parameter, so let's say 3D speed, has changed by this amount, then it will be true. And of course this is each time the logic condition goes through. So this is like 100 times a second. So it's detecting for quick changes. Yeah, so we've got the approximately equals and delta comparators. Next we have some useful timer based features. So these are in the logic switches section. The first one that we're going to get to is delay. Now this one is activating a switch after a period. But for example, let's say that we want this to happen 10 seconds after acro has been enabled. So if we go down here to, we're looking for delay. So it's in milliseconds. So if we put in, so if we want this to activate a second after angle has been activated, we would set it up like this. So when you switch into angle, it won't do anything for a second, and then this will be true until you disable angle. So that is one sort of timer. The next one is edge, which is sort of the opposite. Now, what edge is detecting for is for as soon as something changes. So for example, on OpenTX or EFOS, you would use edge to detect when you get into a switch position, for example, but it would only be active briefly. That's the whole point of it, is you want it to trigger something, but not to be active the whole time that switch is set. So for example, again, we'll use our flight mode and angle. When we switch into angle, this will be true straight away, but on the next loop of the flight controller, it will be false again. So that will literally just be active as soon as we hit it. If we want to have a delay, we can set it in here. So if I put 2000 in here, when we switch into angle, it will be active for 2 seconds and then switch off. So that is how this works. Of course, the angle still needs to be enabled for this to still be on. And the last one is a timer, and this works exactly the same as an OpenTX timer. And again, I believe this is in milliseconds. Yep. So if I set this to 1000 and this to 1000, it will be on for a second and then off for a second. So if I save it, you'll see it's on, it's off, it's on, it's off, it's on, it's off. So there we go. That is the extra changes in the logic conditions. So the enhancement of the waypoint stuff. Now this is what led to those updated operations, is because in waypoints we can now define user actions. So if I pop into mission control and let me just create a waypoint with, or a mission. Let's say, for example, we want to record this little road up here. So let me do that, and then there we go. So let's say we just wanted to record along this little road here. Obviously we're detecting the weather in this region of China. What we would do is we can add a user action. So we have 4 user actions. So we could set this to user action 1, for example. And then on this waypoint here, we could maybe set user action 2. And the idea of using the user actions rather than just using the waypoints themselves is we could repeat this. So for example, let's say, where are we? Let's say at this point here, oh, that looks interesting. So let's put waypoint 6 here, waypoint 7 here, and waypoint 8 there. At waypoint 6, we can activate user action 1. Waypoint 7, we can activate user action 2. So that's our mission. And let's stick that in the flight controller. Also, you notice that waypoint mission 3 doesn't have the a user action, so we can set multiple points in between these two. It doesn't matter. But now if we go back into the programming framework, so what we can do in our programming framework, now we've got a nice clear canvas, is detect these user actions. So let me get some examples. So let's say we want to check that the next waypoint has user action 1. So this will be, if it's true, so we set that to 1. So this will be on the approach to waypoint 2. And the reason why we're doing the approach is so we can trigger stuff. So if the next waypoint has user action 1 and the distance to the next waypoint is less than, let's say, 20 meters, obviously we can trigger this depending on how fast we're flying. And logic condition 0 is true. So if the next waypoint has user action 1, So this is going to be when we're flying towards waypoint 2 or waypoint 6. This will be true. And if the distance is less than 20 meters, then this will also be true. At that point, we can, as a very quick example, this will not work, by the way. This is just an example. We could overwrite our RC channel. Actually, we could make it so it probably would work. We could add an edge, and we're going to be when logic condition 1 is active, and we are going to set this to 50. So that can be on always. So when this is triggered, this will create an edge which will stay active for 50 milliseconds. So it's a very quick one. And if you'd seen my pin.io video, you know why we're going to have a quick one. What we're going to do is then output to an RC channel, and we're going to say we're on channel 16, and we're going to output 1000. Now imagine that RC channel 16 in our modes page is set up to activate user 1 pin.io. So by triggering, we'll say our trigger point is 1000, our not triggered point is 2000. So by having this, our edge condition will now override RC channel 16 with 1000 for 50 milliseconds, which means that we're doing a quick pulse to the pin.io, which will turn our camera on. Then what we need to do is, if our current waypoint has user action 1 is true, and that's going to be an always. Oh, sorry, no, this one needs to be the edge condition. So when this edge is true, that's the only time we want this one active. So we're literally just activating that for a brief period of time to turn the camera on. Now, when the current waypoint has user action 1, so we've just gone onto that waypoint, we again want another edge, and this will be logic condition 4. So when we're flying on that waypoint, and this time we're going to set it up for the length of time to start the camera recording. So maybe that's a 2-second press. And again, we're going to override our RC channel 16, and we're going to set it to 1000, and we only want it when logic condition 5 is active. So you can see where we're going with this. We now have a user action, which when we get close to it, will turn our camera on. When we start flying the waypoint leg with that user action on it, it will start recording our camera. And then we just need to write the logic to do the opposite when we get to user action B. So we'd do it the opposite way round. We would say when current waypoint has user action 2, then do the 2 seconds to stop recording, and then when the distance, because you can do distance from last waypoint, is greater than 20 meters, then we can send the short pulse to turn the camera off. So you can see here how this would be very useful. But anyway, that's gone a bit too further into that subject than I was looking to go, but it just gives you an idea of why that's handy. And the last one, update the flight modes, which will be a very quick one. So just do an equals. In flight modes, we had quite a few before. We've added acro, and we've added waypoint messaging into the flight modes. Also, course hold and cruise have changed slightly. Cruise hasn't changed at all, but course hold has. Course hold originally would have still been active when cruise was, but we've actually made it so that it's distinct. Course hold will only be active with course hold, cruise will only be active with cruise. And while we're talking about the programming, in flight there used to be an is-WP method and some other, I think some other waypoint stuff. This has all moved into this waypoints now. So we have is waypoint, current waypoint action and current waypoint index are all now in this waypoint stuff. And that is why, again, it will be useful to use the tool to convert your diff over from 5.1 to 6.0, as it will take care of these programming framework changes for you. Right, so other changes and fixes of note. So multi-missions, you can now switch multi-mission in flight using a mode. So I don't know if I'll be able to see it, but we should be able to really. There we go, it's in miscellaneous. So we have waypoint planner and mission change. But yeah, so you can add a range to this mission change, and if you have multi-missions, you can use that to go through the missions that you have on your flight controller, select the one you want, and then you can enter into it. Strobe option on LED. I've not actually looked at this, but I believe you can now set, there we go. So we go into color and enable strobe. So there you go, that's where you find that. And it's basically navigation strobes. Increase the maximum safe distance for the first waypoint. This is something that people were asking for quite a lot. Let's go to advanced tuning. I can't remember if it's in here or not. But in originally in INAV, you had, I think, 600 odd meters, I believe, was the original distance for the waypoint. Yeah, so you could be between 100 meters or 650 meters. 650 meters was the furthest away you could have been. And the reason for that is because they used centimeters to set this up. Instead, it's much easier just to use meters, because then we're dealing with smaller numbers anyway. So that has been increased now to a maximum of 1.5 kilometers, and the minimum distance, again, still 100. You can see that the variable name, or the parameter name, has actually changed deliberately, so that you can't just take it over and try and put in a ridiculously high number, because it will just fail. But again, the update tool does take care of this. So if you have 650 meters, that will actually just change that to 650. But you can extend it to 1.5 kilometers. Yeah, so waypoint safe distance, which should be, it is the nav waypoint max distance. You can just change that in advanced tuning now, so that would be 1.5 kilometers. Something that may annoy some people, but is really in there for safety, is that nav extra arming safety off is now no longer an option. You can use allow bypass, which to do that, you just set allow nav extra alarm safety equals allow bypass, or allow underscore bypass. And that means that when you arm, just yaw to the right and then flick your arm switch while holding the yaw. After that, it works exactly the same as it would with extra arming safety off until you unplug and replug in a battery. So it works the same. There's no excuses that if you're in a whoop race and you crash, you disarm an arm and it won't work. It will, because you haven't disconnected the battery. The problem with having it set to off is it's easy to forget about, and people can have flyaways quite easily with this. If you're using a GPS, you really don't want to get to a flying field, have this set to off accidentally, not get a lock, and then need return to home. There is now a setting in launch mode to use manual throttle. Now, I don't know if this is on advanced tuning or you need to set it in the CLI. It looks like it's going to be a CLI setting for this. But what that allows you to do is set the throttle before you launch the plane. And this was mainly in response to people shaking their plane before they throw it. Don't do that. If you're using auto launch properly, you don't need it. With using this manual throttle, it will be a manual throttle. So if you wanted full throttle, you could set it on your stick, but as soon as you set that throttle, the motor will be spinning. So be careful with this setting. And then you can throw the plane. And then the biggest advantage for me is that you could then reduce the throttle as you're climbing out, so you can fly or you can launch more efficiently. Right, auto level now works with course hold. Now this is something that to be honest, I thought it did already. Where course hold doesn't have an altitude lock, I sort of expected that auto level could be used in course hold. It couldn't, but it can now. So you don't just have to use horizon or angle to set auto level, you can be in course hold. All right, waypoint mission landing fixes. There is now an elevation offset. So if you're doing a land in a waypoint mission, it will take the elevation on the actual waypoint into consideration. So that's a nice change, so it'll give you more accurate landings. Virtual pitot is back on in F722 and F4.1, as I mentioned earlier. Flight tracking improvements. Now this is quite an interesting one if you wanted to dive into the pull request, but all you really need to know about it is when you fly a waypoint mission, it will be much more accurate now. So if you want to dive into it, you can. I'm not going to take up too much more time with the video because it's already getting quite long. Right, so consolidate save calls. This is another change that most people don't really need to worry about, but it sort of goes hand in hand with some people having complete firmware wipes. With older versions of INAV, say you had, for example, continuous servo trim enabled, you also had stats enabled. When you disarm, that will actually call two different save requests. And it doesn't need to, it only needs to call save once. So what this does is now effectively say, right, this needs to save. If something else needs to save, it says, right, I'm already going to save, so don't worry about it. And the next loop within the flight controller, it will actually perform that save command. What will be more important for you guys is on the OSD, it will let you know what's going on. In the system messages and also on the stats page, it will pop up a message on the bottom. There are two messages. There are saving settings and settings saved. Now, most of the time, you'll probably only see the settings saved message. The saving settings is pretty quick. Once you see that settings saved message, you know that it's all done and you can safely disconnect the battery without worrying about a full system wipe. Right, course over ground is being used now for the fixed wing heading. And this makes a lot more sense because, again, it doesn't matter about the wind. And what this means is we can now actually use compass on fixed wings in INAV with no problem. There'll be no negative effects from the wind blowing the plane sideways because we're using course over ground for the directionality. Yeah, if you want to run a compass in INAV now, go for it. It's not going to be a negative, whereas before it used to be. Right, fixed wing altitude control. Now, there was a bug which some people may have seen, others may not even know that it exists. And it's a bug that probably did affect more areas than this, but this was one of it that it definitely showed up in. The example for this is if we did a return to home with linear descent, but we actually arrived home before the altitude, it would actually start climbing before it would settle and then start descending again. That's been fixed, so anything else that it may have affected is also fixed. Another one that may annoy some people, but is actually there for safety, and I've also heard the complete opposite where they wanted this to happen, is that navigation modes are now blocked for arming regardless. It used to be that if you had auto launch permanently enabled, you could arm in a navigation mode, which is not ideal at all. All you have to do is then not realize, move the pitch and roll stick, which exits auto launch, but you're in a navigation mode then, which will then start the throttle spinning because it's got auto throttle. And there have been instances where people have had this happen to them, and luckily it's just caught them by surprise. They've not actually been injured. So from now on, you can't be in a navigation mode when you arm, and that's blanket across the whole system. If your auto launch was on a switch, you had to obey this anyway, so I don't know why this special case was made for permanently enabled auto launch in the first place, because it doesn't actually stop you doing what you want to do. You just have to follow the procedure, which I've been putting in my videos for a couple of years now. And that is, number one, be in a non-navigation flight mode. So that can be manual, acro, angle, or horizon. Doesn't matter, any of those four, they're not navigational, you can be in that flight mode. Number two, enable auto launch, which you can be on your switch, or if it's permanently enabled, it's already done. Number three, arm. So now you've armed your motor, you can change the flight mode to what you want to exit to. So for example, put it in loiter. This is a navigation mode, but because we're going through this procedure of arming and then actually putting it into the navigation mode, rather than you could be in a navigation mode and not realize it, we're explicitly doing this task. So if then we exit launch mode, there's nothing really that we can do to prevent that from spinning up. but it gives that extra step so that you are actually specifically doing it. Loiter, that is a very good one, because when you throw it, it's going to stay in front of you and then start loitering. You can see where it is. Return to home comes back over your head, you can't keep an eye on it. So loiter is a better option. 4, increase your throttle to the exit throttle. So this is your cruise throttle, maybe 50%, whatever. Then either idle is going to activate if you've got that set up, or you just throw it. And that's it. So other than when the navigational mode is selected, there's no real difference. You're not missing out on anything. It's just extra safety. So that's why that change is in there. Now, configurator changes. We're getting close to the end. Right, expanded labels. Now, what that basically means is you can see these little unit labels down the side here. You might not know exactly what they are, but now if you hover over them, it will tell you. So MS milliseconds, S is seconds, US is microseconds, M is going to be meters. It will let you know what those labels actually mean. Right, the GPS page. So that's not that one, that is that one. Sorry, it looks really crap all crunched up like this. But the time zone offset is now in hours and minutes. Originally it was in just minutes, which most of us, if we have an offset, is going to be in hours. So now you can just set the hours to like 1 hour offset rather than having to multiply it by 60. Also, there should be a warning somewhere. That's not going to be here for much longer. So if you're using NMEA, chances are uBlock 7 will work, if not uBlocks. Nav pause hold. So I want modes, that one. So if we go into our navigation modes, we can see we have nav loiter. This is a fixed wing. Every time we talk about position hold on a fixed wing, we say loiter. So on the modes page, this is now saying nav loiter rather than nav pause hold. If you're flying a multi-rotor, then position hold is more relevant, so it still says nav pause hold. It's the same mode, it's just the text that's changed. And coming up in the future, and on the OSD, it will say loiter rather than hold as well. So that won't be in this version, but it will be in a future version. Auto target detection on the firmware flasher. Right, so if I disconnect and go into firmware flasher, you'll see that it knows that I'm running a Maytech F405 SE target. And I can choose whichever firmware I want for that target straight away. It just takes that one step of going through this list out. If it doesn't work, you could try this auto select target, but usually it will work when you plug in, but it will only work from INAV 5.0. Well, it says 5.0 here. In here it says 4.1. So maybe it will work with 4.1. I know that there was an MSP change that was necessary for this to work, but I can't remember which which version it is. But it will definitely work with 5.0. There is a 7-inch profile for quads. So if you do flash your firmware, when you first connect, you get that defaults box come up. There's now an option for 7-inch quads. Updates to the advanced tuning page. There's quite a few, to be honest. And most of it is just rearranging stuff to be more intuitive, but also more features have been added. So the grouping in this section, for example, like things are grouped together. There are some extra settings in here. There are quite a few extra settings actually for the return to home. So we have the first stage climb is now in here. Trackback is in here, so we can set trackback to on, so it will work with return to home and failsafe, or failsafe only. Trackback distance, oh, you can set it in here. So there we go. So there's a lot more options now inside the advanced tuning, which is fine because it is an advanced page. If we go to the mixer, the output mode is now an option here. Most of the time you're just going to use auto, but if you're using like a quad ESC which only got 4 outputs and you want to use it on a plane, so you may find that 2 of those are set for motor, so you can set them to use all servos, and then set up a stabilized throttle for actually providing the output pin for the motor. So again, it's not going to affect a lot of people, but it is useful. And also you can set everything to motors as well, which, for example, if you've got a quad and you've only got 8 outputs, sometimes some of those may be set up for servos, but you can then just say, no, I want them all as motors. So that option has been in INAV since I think 5.0, but now you can just set it on the mixer page. Right, reset button for the accelerometer. This, when it was first put in for I think FP1 or RC1, confused quite a few people because originally it was red. So people thought that their configuration was incorrect. It wasn't. It was absolutely fine. What this does is allow you to reset the calibration if you're not happy with it. So if you're perfectly happy, then don't worry about this button at all. And the reason it goes red is a warning that it's going to wipe your configuration. But so for example, we find that for some reason we're not happy, there's something that's going wrong. Before we would have to go into CLI and reset all these values. Now we can just click this button, it will reset, and then when you come back, it will have the calibrate accelerometer button back for you. Right, default baud rates on the ports page. Some things need specific baud rates. So I think if Smart Port Master, you can see it's now set to 57600. There's other things as well which will set different baud rates. So FreeSky OSD. If not, it will default to the standard. But anything that was known about has been added so that it will set the correct baud rate for you. Right, link to documents for correct firmware versions. Now again, this is something that you probably won't even notice, but will help you out. So if I click somewhere, you see all these question marks. And I think it might actually be set on these as well, but definitely on the question marks. Here, for example, we are looking at the voltage source, and there we're looking at the current sensor scale. If we click on the question mark, it would actually take us to the correct parameter in the GitHub. The problem with this is this document actually changes all the time that the version changes. Going forward, when you click these buttons, it will actually take you to the documentation for the correct version. So it's not really going to be noticeable in 6.0, but going forwards it will be. So if we're using an older firmware, we click the question mark, it will actually take us to the correct page for that firmware. And that's quite important because, for example, this parameter may be removed. So when you got to the page and it's using the latest version, it might not even be there. But also the way it works may change as well. So you'll get different descriptions, that sort of thing. This just ensures that you're taken to the correct documentation. Right, auto. Let's go back to the modes page, which is that one. Usually when you add a range, you would need to go through this list and choose the channel. Now you can just choose auto, move the switch, and it will automatically detect it for you. And the final thing is really just a bug fix. So in the last version of INAV, after you've done a flash, you get that box pop up. And when you chose that option, it would automatically load and save a mixer for you. Now, if you chose airplane with a tail, it wouldn't actually save that it can use flaps. So let's find the mixer again. And the same actually happened if you clicked airplane and load and apply. If you clicked airplane and just load, it worked. But this has been fixed now. So it will automatically know that you can use flaps. So you have the flapper on mode here, and you would have the flapper on mode in the modes page. So it's just a little fix, but some people did notice it. So that's why I've included it in this documentation. I think that's good enough for now. This video is going to, well, I'm imagining it's going to be an hour-ish long. So that should get you started. I'm actually recording this about a week and 5 hours before INAV 6.0 drops. So unless there's any actual last minute changes that go in, this, as you've seen here, is as it will be. But I hope you found this video useful. Oh, I haven't finished. I keep mentioning this tool in the video. So let me go to the release notes. Right, so here are the 6.0 release notes, and these may change slightly when 6.0 actually drops. but you'll see in the updating it mentions running your 5.x diff through a tool. The tool will update some parameters, but it's still worth double checking through all these release notes just to make sure that it does everything correctly for your setup, because there's some things that it may not change, but you want them to be updated. But the tool is quite simple to use. What you would do is, I've closed INAV. If you'd go in to CLI, do a diff all, paste that in there and click update diff, it will provide you with an updated diff. So you can see here basically what it changes. It will update the logic conditions, so any operands that you're using will be updated from the old ID to the new ID, so your logic conditions should be correct. It will update the nav waypoint safe distance, so that what you've got currently set will be set in the new version. It will update nav extra arming safety, so if you've got it set to off, it will set it to allow bypass so you can still use that functionality. It will try to set the AHRS mitigation parameters. Now, most of the time, this is just deleting what you've currently got, because the new parameters are using different parameter names. So if you put your old one into the diff, you'll get a load of errors where they are no longer parameters in the system. But also there is something quite important that you need to check up on if you're using fixed wing. And I'll go back to the release notes in that to show you. But if this can work out that you are using a fixed wing, it will add it for you. There will be notification messages at the bottom, so please read those, just making sure you check this because it's quite important. And the OSD horizon offset, as I've mentioned, if you're using an offset in the CLI, it will set it correctly for you. Please don't take this as an excuse not to use not to read and check the release notes. They are still very important. And also, this is only for 5.0 or 5.1. If you've already been using FP1 or any of the release candidates, do not run that diff through this, because then you'll effectively be changed data. So this is only for 5.0 or 5.1 diffs. If you're using an older version, go through the steps to update the diff to 5.1, or to be honest, start from scratch. Just take over stuff like the OSD and your modes, that sort of thing. If we pop back into the release notes, it does say pay special attention to the AHRS inertia comp method, and that's discussed down here. So if you're flying a quad, then you can just ignore all the AHRS stuff, because the old values that have an IMU prefix will just be ignored. They'll come up as errors, so you can ignore those errors. And the new values have AHRS, and the defaults are absolutely fine for pretty much everything. The inertia comp method by default is fine for quads, but if you're using a fixed wing, you need to set it to adaptive. Also, if you're using fixed wing without a GPS, pay special attention to that bit there. But as I said, read the release notes. Read the release notes. So there you go. I hope you guys enjoy INAV 6.0, and again, whatever version you are on, unless you are running an F3 flight controller where you don't have any choice, update. 6.0 is a reboot for INAV. It's so much improved. We've had die-hard RG-plane people flying it and saying, right, I might even move over. It's that big of a change. It's well worth certainly updating any previous version of INAV 4. And if you are an RG pilot person, on your next build, maybe try it out. You know, worst case, you'll have to reflash, but at least you can see what's happening. And to be honest, there are some things that INAV does do better, and of course there are some stuff that RG plane does better. So at least having that understanding, you can choose which is best for that particular plane. But anyway, I hope you guys enjoyed the video. If you did, please remember to give it a thumbs up, click the subscribe button and the bell icon. That will help get this video out to more people so they can learn what's changed in INAV 6.0 too. And most of all, fly models like you stole them, have fun. That's why we all do this, right? See you later.